For section 1.1 in your textbook, this is pages 9 and 10, I've selected problems from your homework assignment, and I hope this video provides help for those who may need it. But just want to always encourage you to please don't stop with just this video. Make sure after you've gotten some help with this video that you turn around and make sure that you can work through these problems yourself successfully, and maybe do that multiple times over the course of the several days leading up to the test. So don't just watch and record and let that be the end of it. Make sure that you have understanding. This is merely designed to be a way to get you thinking, provide some guidance for some of the more, hopefully, the difficult problems. So this is number 25. As you can see, our instructions are to take this verbal expression and change it into an algebraic expression. And we talked in class, we're looking for keywords and phrases that refer to mathematical operations, or in some cases words that refer to exponents, something raised to a power. Well, the beginning of this phrase says 5 more than, okay? And the more than, we talked earlier, refers to addition. So the way I express 5 more than is with a plus sign, obviously, and then 5. So taking 5 and then adding it to something. And the something, if we keep reading, will be the quotient of a number and 4. Well, a number is obviously going to be what our variable represents. So the way we do the quotient of, that's just another way of saying division. So we're going to have some number divided by 4. Okay, so what we've done here is we've taken this verbal expression and we've converted it into an algebraic expression. And don't get caught up if you use a different variable besides n. That's okay. No problem there. All right, so that's your answer for number 25. Let's move on. Number 27. Let's see. Our instructions here are to write a verbal sentence. So we're going the other direction. Write a verbal sentence to represent the equation. Okay, so I mentioned earlier, and it's not necessarily, I'm not going to hold you to this, but we talked earlier about how we're thinking in terms of reverse PEMDAS, because that's what guides us, that's the guiding principle when it comes time to solve these for a particular variable, which is what's coming up in just a few minutes. So I just want you to go ahead and start phrasing this out using this same progression, starting at the bottom of PEMDAS and then working your way up. So remember what we talked about in class, that the x plus 3, since they are unable to be separated in the division by 4. If you divide 4 into x, then you must divide 4 into 3. There is no other way around this. You have to keep this numerator together as a group, and so therefore I always recommend students in cases like this where the variable is contained in the numerator of a fraction and there's an operation involved. So now I would encourage you to put parentheses around this numerator, because when we mark off the parts of PEMDAS that are now showing, we're going to undo division, and then we're going to undo whatever's in parentheses. Okay, I've noticed over the years that encouraging students to put parentheses around the numerator like this and then treating it as the p in parentheses, doing that part last, keeps people from making a pretty common mistake. And I don't even want to mention what that mistake is, because I don't want to put bad thoughts in your head. So I would recommend this. Maybe you can get this right without it, but I strongly recommend. So thinking about PEMDAS in reverse, let's phrase the division part, and the word that we've been using to represent division, of course, or the phrase, is the quotient of. Okay, so the quotient of. All right, and now we just have to tell, well, what is it that's being divided? Well, let's just start with the numerator. And there's a couple of ways of doing this. You could say a number increased by 3. You can say the sum of 3 and a number. There are many right answers to this. Okay, so that's the top part. We have the quotient of, which takes care of the dividing line. The sum of 3 and a number, which takes care of the numerator. And now, what are we actually dividing by? And that will be the denominator, 4. And we use the little word is to represent the equal sign. And there we have it. And again, if you phrased it a little differently, maybe you've already done this and you're just watching to check your answer, and maybe yours is phrased a little bit differently, but it's got the same gist, then it's okay. No problem. Okay, number 29 it's a word problem, and I thought I'd provide a little bit of help because some people struggle with interpreting these word problems and correctly writing the algebraic expressions and equations that are involved. So you have your book there. These are actual current players during a recent season. Miguel Cabrera and Mike Jacobs hit a combined total of 46 home runs. Here's a key sentence. Cabrera hit 6 more home runs than Jacobs. How many home runs did each player hit? Define a variable, write an equation, and then solve a problem. So the first part of that last sentence, excuse me, is to define a variable. So I'm just going to let the variable n represent the number of home runs. Jacobs hit. Now, why did I pick n to represent Jacobs and not Cabrera? Well, we're told in that middle sentence that Cabrera hit 6 more than Jacobs. So remember earlier, in some earlier examples, the way we expressed more than is with addition. So if I take Jacob's number and increase it, addition, by 6, then I've got the number of home runs, just abbreviate, Cabrera hit. Okay, so Jacobs is in, and Cabrera will be 6 more than Jacobs. Well, combined, they hit 46. Well, combining implies addition. So let's take the variable that represents Jacobs and the expression that represents Cabrera, add them together, and combine. That total should be 46. So combining like terms, we get 2n plus 6 is 46. 2n, subtracting 6 from both sides, is 40. And so n is 20. So let's go back to the definition of our variable. N stands for the number of home runs Jacobs hit. So I always like for you to write the answer to a word problem using sentences if necessary. Something like this would be okay. Jacobs hit 20 home runs, and Cabrera, since he hit 6 more, hit 26. Okay, and that will be it. So good little problem in training us to take English words and convert them into algebraic expressions and equations. Okay, next page. This is number 42. And this is going to involve the distributive property, but I'm doing this because fractions give some people a little trouble. We did a problem like this in your notes, but I'll work through this one as well. So there's two ways of thinking about multiplying 3/5 times 15. Personally, I like to divide this denominator 5 into 15. If I divide 5 into 15, I get 3. And then that result, 3, I'm going to multiply. Okay, so it's division from the bottom and then multiply the result. 3 times 3 is 9d. Okay, and don't forget, distributive property means I also not only multiply by 15d, but I also have to multiply by 20. So I'm going to use that same process. I'm going to divide 5 into 20, and that's 4. And then 4 times 3 is 12. Okay, that takes care of that group. And now we're going to distribute, I'm going to think of this as negative 1/6 to both of these terms. So if I multiply negative 1/6 times 18, that's negative 3d. And if I multiply negative 1/6 times negative 12, that's positive 2. So, real quickly, an important first step when you're solving for a variable, you must remove all the grouping symbols, and usually that involves the distributive property. Okay, so don't forget, remember CLT, combined like terms. I got a couple of d terms. 9 minus 3d is 6d. And I got a couple of constants. 12 plus 2 is 14. And that equals 38. I'm going to subtract 14 from both sides. 6d is equal to 24. And therefore, I can either think of division by 6 or multiplication by 1/6. Either way, I get my final solution for d, which is 4. Okay, and I'm going to trust you. This is you're on your own as far as checking. So do what you will. All right, I think this is my last one. And in this section, we're trying to isolate a particular variable. The instructions say to solve each equation or formula for the specified variable, which is another way of saying, in this case, let's get z by itself on the left side. And once again, it's important to understand that the way to do that correctly is to follow PEMDAS in reverse order. Okay, we're going to go up the PEMDAS ladder. So I always like to encourage people that maybe struggle with these. Let's just go ahead and maybe circle the variable that you're told to isolate. And then let's mark off in this PEMDAS list, let's mark off what is being done to z. What operations are being performed on z? Well, multiplication by y, so I'm going to put a check by the m, and then I'm adding this other term wx, so addition is also involved. Well, if I start to undo these in reverse order of PEMDAS, that means I'm going to start with undoing, I checked subtraction. Why did I do that? Sorry about that. I'm going to start by undoing the addition. Okay, so the way I undo addition, of course, is with subtraction. So I'm going to show these steps. I just subtracted wx from both sides. All right, and now it probably looks pretty easy to figure out how we're going to solve for z. We just have to undo this multiplication. All right, we've already taken care of undoing addition. Now we undo multiplication with division, or multiplication by the inverse, but I'm just going to show division. So divide by y in this case. And that's going to get us to our final answer. Z is the fraction bc minus wx over y. All right, and that should be your answer for number 50. Okay, so hope that helped. That's just a select few of the problems on your homework assignment, but if you need further help, come and see me either before or after school, and be glad to help you. But make sure you work on these yourself. When you come for help, you should have something that you've tried. Make sure that you make a strong attempt, and then if you're not sure, or if you need further a little push or a nudge, feel free to come see me.